So for systems of equations, basically what you have here are two equations of two different lines. So we have one line here, y equals negative 3x minus 4, and the other is y equals 4x plus 3. First thing we need to realize, excuse me, is our slopes do not have a denominator, so I'm going to put a 1 under them. So over 1 over 1. Now, I'm going to graph the first line, and the first thing I notice is the y-intercept is at negative 4. So I'm going to put my first point at negative 4. Then my slope, rise over run, is down 3 and right 1. Well, I can't go down 3 and right 1 because I've run out of room. So instead, I can go up 3, 1, 2, 3, and left 1. Instead of down and right, I can go up and left. And I can do it again. 1, 2, 3, left 1. 1, 2, 3, left 1. And I know I did it right because the line is going downhill. And I know it's downhill because of that negative slope. So now I'm going to do the other one. I'm going to do it in a different color so you can see the second line starts at a positive 3. And the slope is up 4, right 1. Well, again, I can't go up 4 and right 1, but I can do the opposite. I can go down 4, 1, 2, 3, 4, and left 1. 1, 2, 3, 4, and left 1. And here's the line. I know it's uphill because the slope is positive. Now, the purpose of this systems of equations is to find the solution is where the point where the lines touch, if they do. And they do right there. So the solution is the point, negative 1, negative 1. So basically, I could check myself. If I plugged in a negative 1 here and a negative 1 here, it would work. And a negative 1 here and a negative 1 here, it would also work. But basically, it's where these two lines touch each other. Now, if we look at this one, I notice something right away. I notice this and this. These two both have a slope of 3/4. So when the slopes are equal, when are they ever going to touch? They're not. If you have slopes that are equal, those lines will never touch because they are parallel. So they'll never touch. So honestly, I don't even need to graph those. I know this is not an option, so my answer is no solution. Again, that is when your two slopes are equal, makes parallel lines. Never touch. Okay, here we have two lines. We'll start with the first one. The y-intercept is 1, so I'll put a dot at 1. And then my rise over run is up 1, right 2. Up 1, right 2, up 1, right 2, or down and left, down and down 1, left 2. And then I'm going to connect my line, or connect my dots. So that's for the first one. Now the second one is something special. We have x equals a number. Well, I'm going to go on the x-axis, and I'm going to put a point on that number 2. Right there. Now, I know, and hopefully you know, that when you have x equals a number, that is a vertical line. Straight up and down. So I will draw a line through 2, right there. And so right there is my solution. It's where those two lines touch, and the coordinates is 2, 2. That's your solution to that one. Make sure you remember, make note that vertical lines are when you have x equals a number. Then my last example, I'm going to do the bottom one first, just because I think it might be a little easier for you. You have y equals negative x. Well, that's a negative 1 over 1. When there's no numbers there, we're going to make it a 1. And then your y-intercept is negative 1. So start with my y-intercept at negative 1. And then this is down one, right one, down one, right one, down one, right one, down one, right one, down one, right one. Or up and left, up and left, up, left, up, left. I'm going to do it till I run out of room. Connect the dots. Now my other one here is when you have y equals a number. And y is going to equal -4. So I'm going to go on the y-axis right here. And I'm going to -4, and I'm going to put a point. Anytime you have y equals a number, it is a horizontal line. Horizontal line like that. When you have y equals a number and there's no x in it. So back to here, draw a line, horizontal through -4, and here we found our solution. The solution is where the lines touch, and the coordinate for that specific point is 3, -4. Solutions to systems of equations, solving them graphically. Now, one other that you may come across is one that looks like this. You have a y equals 5x plus 2, and then maybe another one that says 2 plus 5x. Well, essentially, that is the same line. They just reverse the order of your slope and y-intercepts. So if I were to graph that, it would literally be a line, and then I'd graph the second one, and it would be the same exact line on top of each other. So when you have these two lines that are exactly the same and they're graphed on top of each other, where do they touch? Well, they touch everywhere. So the answer is infinite solutions, because they touch everywhere because they're the same equation written on top of each other. It just may have moved things around a little bit.